Right. Hey everyone. So today we're going to be covering week 5 questions. Again, you can find them in the course materials page. They're going to be linked pretty much in the same area you're finding these. And then I encourage you to work on them on your own first. Hope everyone's doing well. We're going to go ahead and get started on number 1. So number 1, we have some setup here, some metal wires, and we have a current I sub A flowing through this parallel section. Then we have I sub B, I sub C, and I sub D. And what they're asking us to do is rank them in order from largest to smallest, right? So just using Kirchhoff's laws, right, we know that the amount of current going into a node has to be equal to the amount coming out of a node. So right off the bat, we can say that IA is greater than both IB and IC because we know IA is equal to IB plus IC. And we can also say the same thing about ID, right? IB and IC come down, they hit this kind of intersection right here and then split back into ID. So we can say also that IA has to equal ID just because the current that went into that portion comes out in an equal amount. So IA equals ID. And then this is going to be greater than IB. And since everything is symmetrical, I haven't drawn it that way here, but it says it in the problem. We can say that IB and IC are also equal, right? If there's not more resistance on one side than the other, if it's equal, then that current should split equally across that parallel portion. So that's going to be the answer for this one. And let's go ahead and move on to number 2. All right, so number 2 wants us to find the equivalent resistance between points A and B. So this is going to be similar to week 4's problem with capacitors. The only thing is with resistors, right? So kind of starting with these two, resistors in series add normally, as opposed to capacitors. Capacitors in series add the inverse, right? So for these, we're just going to add, we want to start with the ones that are already in series normally, just because it makes our life much, much easier. So we can do this total resistance here. I'll just call this R1 for now. R1 is equal to 10 plus 40, so it's just going to be equal to 50. We also want to do the same thing with these guys, so R2, that's going to be equal to 55 plus 20, which is in total equal to 75. So now we can redraw our circuit like so. And now we have 50, 75, and 10. So we need to combine this parallel portion here. So the 50 and the 75, I'll just call it RP for like R parallel. This is going to be, now we want to do the inverse, right? So this is going to be 1 over 50 plus 1 over 75 to the negative 1. And then combining these, we're just going to end up with, I believe, let's see, I believe I wrote it down here. Yeah, so this is going to give us 30. And then from there, we just need to combine these last ones. We have 30 here and we have 10 here. And we just combine these as normal. So in series, right, our entire thing, once we've condensed it all into a single R equivalence, it's just going to be 30 plus 10, which is going to be 40. And then these are all just in ohms. So there you go. That's going to be the answer for number 2. If you have questions about it, leave them in the comments, and then we'll go ahead and move on to number 3. So here's going to be number 3. This one's slightly different from what we've been doing. So we're given an amount of current flowing into a section of wire with resistors in parallel, and we're given what the potential difference over that portion is. And what we want to know is what is the value of this resistor right here. So there's a few ways to kind of look at this. First, what I'm going to say is I want to combine all of these resistors into one R equivalent. And the reason for that is I know how much current is going into this entire section, and I also know the voltage drop over this section. So if I know the current and the voltage drop, then I effectively know what R equivalent is, and I can kind of solve for R like that, right? So I can say R equivalent is just equal to, in general, delta V over I. That's coming from Ohm's law. And then using just how we add resistors in parallel, it's going to be this 1 over 10 plus 1 over 15 plus 1 over R, this R that we're looking for, right? And then it's to the negative 1. So now we just need to start solving for this 1 over R. So first, right, just take the inverse of both sides. I'm going to have I over delta V. And then combining this 1 plus 10 and 1 plus 15 is going to give me 5 over 30 plus 1 over R. And then now I want to keep, just solving for R. So I'm going to have I over delta V minus 5 over 30. This I over delta V is going to give me 1 over 4. So I'm just going to, I is 2, V is 8, so 1 over 4 minus 1 over 6. I want to take the inverse of both sides. And solving for all these numbers numerically, what you're going to end up with is that resistor has a resistance of 12 ohms. So hopefully this was helpful. If you guys have specific questions about these problems, feel free to leave them in the comments. If you have more general questions, hopefully I'll see you in SI to help out. I suggest going to office hours as well. You can also hit me up through email, which will be in the description. But other than that, hope you guys are having a good week. Hopefully studying good for the midterm, taking care of yourselves. But other than that, have a good one.